In this class, I'm going to be introducing you to the four equations used to solve uniform acceleration. We call it four equations of motion. Now, what is acceleration? When we talk about acceleration, we are referring to the change in velocity over the time taken for this change to happen. Now, when a question is being given to you that a body at rest has its initial velocity, and by now I hope you understand what velocity is. That's displacement over time. When we are talking about the initial velocity of a body at rest, it is said to be zero. Of a body that is not moving, the initial velocity is said to be zero. And we have acceleration to be final velocity, that's the maximum velocity attained, minus the initial velocity, that's the first velocity in that question. It can be at rest, or it can only be given to you in the question that the initial velocity is this value over the time taken for this acceleration to occur. That's why we said we have acceleration to be final velocity minus the initial velocity over time. Now, the four equation of motion is used to do some calculation of a body accelerating in a rectilinear form. The first of all is v equal to u plus at. So we have the first equation to be v equal to u plus at. This is the first equation of motion which is being used to solve rectilinear acceleration. Now, the second one is s equal to ut plus 1 over 2 at squared. And the third one, we have it to be v squared equal to u squared plus 2as. Then the fourth one, we have s to be v minus u, everything into bracket t over 2. Depending on what you have here, you can have it to be plus or minus, plus or minus, plus or minus, plus or minus. Depend on what the question, if it is either accelerating or decelerating. Now, let's see what all this means. When we talk about v, we refer to the velocity of the body. And when we talk about u, we are referring to the initial velocity of that body. And when we talk about a, we are referring to the acceleration of the body. And when we talk about t, we are talking about the time taken for this to happen. And the s is the distance. We refer to the s as the distance of the body. Now, these are the parameters we are going to use in solving acceleration of a body, uniform acceleration of a body. Now, most of them will be a little bit confused that, okay, if I'm having a question, which of the four equations am I going to apply to it so that I can have get my final answer? Now, in this course of study, I'm going to be explaining to you how to make the right choice of equation for your question. Welcome back, guys. Now, the first question we are going to be picking under uniform acceleration of a body is this. A particle accelerates uniformly from rest at 6.0 meters per second for 8 seconds and then decelerate uniformly to rest in the next 5 seconds. Determine the magnitude of the deceleration. Now, this is how to make the right choice of your formula or your equation that you are going to make use of in this. Now, write out the data that you have in the question. A particle accelerates uniformly from rest. When you are being told that a particle accelerates from rest, it means the initial velocity of that body is 0 meters per second. At 6.0 meters per second square. Now, this unit connotes or it means acceleration of that body. So I have the acceleration to be 6.0 meters per second square for 8 seconds. That's the time taken for this to occur is 8 seconds. Then decelerate uniformly to rest in the next 5 seconds. Now, the first thing you are going to do is to calculate for your final velocity when this acceleration happens. What's the final velocity of this body when it accelerates at 6.0. Now, if we can kindly go back in that formula that we have, the best formula that is suitable to solve this question is V equal to U plus AT. Now, we were told that the body is at rest. That is, the initial velocity of that body is 0. So we are going to have V equal to 0 plus, what is the acceleration of that body? That's 6. So we have 6 multiplied by what? That's the time taken, which is 8. Now we are going to have our velocity to be 48 meters per second. Now this is the first value. That's when the body accelerates to its maximum velocity. Now what happened? The question continues, and decelerate uniformly to rest in the next 5 seconds. Now there is another time taken for it to decelerate again, which is 5 seconds. And we're told that the body decelerates. Now after it accelerates to its maximum velocity, okay, that maximum velocity it has before decelerating become the initial velocity. So we have this one to be what? 48 meters per second. Why am I using 48 meters per second and I'm not making use of 0 meters per second? When the body gets to its maximum value or maximum velocity, the maximum velocity there before the body starts decelerating virtually become the initial velocity of that body. That's why you see me using U now to be 48 meters per second. Now what's going to be our V? We're told that the body decelerates uniformly to rest. That is, our final velocity equal to 0 meters per second. Now, what is the question? We are asked to determine the magnitude of the deceleration. Now, let's kindly determine that the best formula for this is also V equal to U plus AT. Since it's deceleration, we are not going to be making use of plus again because the body is decelerating. Now, it's going to be what? Minus, because of the deceleration of that body. But at the end, we are still going to arrive at our minus. So let's go. This is 0 now. The initial velocity is 48 plus. We are looking for the acceleration of that body, and that's going to be what? A multiplied by the time taken for this to happen is just 5. So when we multiply this, we should have 48 plus 5a. So let's collect like term. This is going to come here. We have 5a equal to what? 48. Then we divide both sides by 5. When it's coming here, it becomes a negative sign. So we divide both sides by minus 5. So the acceleration of that body become a negative 1 because we are solving for deceleration. And that should give us minus 9.6 meters per second squared. Now you see that the deceleration of the body is coming with a negative sign because it is deceleration. We're told that deceleration is the negative form of acceleration. Now let's quick do recap of the question. The first thing you need to do in this type of question is to get the maximum velocity of that body. And when you say the maximum velocity of that body is 48 meters per second, at its maximum, the final velocity before the body starts decelerating becomes the initial velocity. That's why we are using the initial velocity to be 48. And we're told that the time taken for it to decelerate is just 5 seconds. And the final velocity becomes 0 because the body comes to rest at that point. Now, we apply the same formula again and we collect like time. At the end of the day, we have minus 9.6 meters per second squared. Now, let's proceed to another question. Alright, my wonderful learner, in this second question, let's see what we are asked to do under the uniform acceleration of a body using equation of motion. Now let's look at this. A body starts from rest. One thing that I like about physics is that in uniform acceleration, when you are being told that a body starts from rest, it means that the initial velocity of that body is 0. Now, let's say, for example, the question didn't come with a body start from rest in uniform acceleration of a body. You are not to make the initial velocity, okay, to be 0. The initial velocity should be that first velocity given to you in that question. That's where the velocity starts from, where they want you to put into consideration. But when you are told that the body starts from rest, the initial velocity of the body is 0. Now, let's go back to our question. A body starts from rest. That is, my initial velocity is going to be 0 meter per second. And accelerate uniformly at 5 meter per second. That's our acceleration equal 5 meter per second. Until it attains a velocity of 25, we are told that it has a velocity of 25 meter per second, which is the final velocity. When it starts from rest, it attains its maximum velocity to be 25 meter per second. Now, we asked to calculate the time taken to attain this velocity. So in this question, we are looking for the time taken in seconds for this body to attain this maximum velocity. So the best formula to solve this, if we are to go through all the formula that we have earlier on, is V equal to U plus AT. So we have V equal to U plus AT. Now let's apply it. We have our final velocity, which is 25. We have our initial velocity, which is 0. We have our acceleration, which is 5, multiplied by the time taken, which we are looking for, which is t. Now 5 multiplied by t, we are going to have 25 equal to 0 plus 5t. Then 0 plus 5t will definitely give us 5t. The next thing to do here is to divide both sides by the coefficient of t, which is 5. 5 in 25, that should give 5 seconds. So if you are to look at this question, this body starts from rest and accelerates at 5 meters per second. We found out that it has attained its maximum velocity to be 25 meters per second. Now the question, what is the time taken for it to attain this maximum velocity it has? And if you have to check all the formula, the best one or suitable to solve is V equal to U plus AT, because it has what you are looking for, and all these parameters, we have it in the question. When we substitute, at the end of the day, the time taken for this body to attain its maximum velocity is just 5 seconds. Welcome back, my wonderful learner. In this question, it's a little bit different from what we've been solving. We've talked about the standard unit used in physics, which we have the length to be in meter or distance to be in meter. We have the mass to be in kilogram. We have the time to be in second. Now, what if time is given to us in hour? What do we do about it? If time in question is given to you in hour and the answer is being expressed in the standard unit, all you have to do is to convert that hour to second by dividing the value or the magnitude that you have by 3600. If it is in minutes, you just divide it by 60. Now let's check the question that we have here now. A motorbike moving with a velocity of 3 km per hour. The velocity of the body is 3 km per hour. I've explained to you in our previous question that if the question did not start with initial velocity or a body at rest, and you're just being given the velocity, it means the initial velocity is that velocity given to you. Example is this type of question: a motorbike moving with a velocity of 3 km per hour. It is wrong for you to use the final velocity as 3 km per hour. So we have our initial velocity to be 3 km per hour. Now let's move on. Accelerate uniformly for 10 seconds. So we have our time to be 10 seconds at the rate of 0.1 meter per second square. That's our acceleration. The unit will define the type of quantity. So we have the acceleration to be 0.1 meter per second square. Calculate the distance. So we're checking out now for the distance. We can just go into the question to solve, because let's check the option. The option is in standard unit, which is meter, and that's for distance. So we can, had it been in kilometer, we'll convert this time to hour, then we go ahead and solve. But now we did not have it like that. We have our unit to be in meter. That is, we are going to convert the initial velocity of that body to the standard one, which is meter per second, not kilometer per hour. When we say 1 kilometer, it means 1000. Per hour means 1 over that time. So let's do the conversion. We have the initial velocity, which is 3 multiplied by kilometer. 1 kilometer is 1000. So 3 multiplied by 1000 multiplied by 1 over this is inverse. That's why I'm having 1 over now 3,600. At the end of the day, I should have 3,000 over 3,600. So this cancel this cancel out this. So my initial velocity is 0.83 meter per second. You can see how I just simply convert my initial velocity from kilometer per hour to meter per second, which is the standard unit. Now it's in kilometer. Kilometer means 1,000. Sorry. That's why you see that I'm multiplying it by 1,000. Now per hour, because of this inverse, that's why I have 1 over hour to seconds is 3,600. That's why I'm dividing it by 3,600. At the end of the day, I arrive at 0.83 meter per second squared. Now let's input what we have into our equation, ut plus 1 over 2 at squared. So we have s equal to, the initial velocity is 0.83, so we have that to be 0.83 plus 1 over 2 multiplied by our acceleration given in the question is 0.1, so we have this to be 0.1 multiplied by the time taken is 10 seconds, so we have 10 square. So if we simplify that, we have our distance to be 0.83 plus 1 over 2. Okay, now we haven't multiplied by the time, if I can still remember. So we have it to be multiplied by 10. Here also should be multiplied by 10 plus 1 over 2 multiplied by 0.1 multiplied by 100. Sorry for this part. This part is the initial velocity multiplied by the time, and the time taken is 10. So that's why I have to go back and redo that. Now we have our distance to be 0.83 multiplied by 10 gives 8.3 plus 1 over 2 multiplied by 0.1 multiplied by 100 gives 10. So in that case, we have s equal to 8.3, 2 here 1, 2 here 5. We have 8.3 plus 5. At the end of the day, we have 13.3 meter. And if you have to check the option, we have A, which is 13.3 meter, which is the distance covered by this body. Alright guys, we have another question on the board that we have to solve now. Let's quickly go through the question. A body starts from rest and accelerates uniformly at 5 meters per second squared. Calculate the time taken by the body to cover a distance of 1 kilometer. So let's put out our data. A body starts from rest. We know that our initial velocity of the body is 0 meters per second squared, per second rather. Accelerate uniformly at 5 meters per second squared. So we have our acceleration to be 5 meters per second squared. Calculate the time taken by the body. So we are checking out for the time taken of that body to cover a distance of 1 kilometer. So as our distance is 1 kilometer. Now it is wrong for us to make use of this 1 kilometer in solving, because all we have here is in standard unit. We need to convert this 1 kilometer down to meter. And what is 1 kilometer down to meter? 1 kilometer is simply 1 multiplied by 1,000, and that is 1,000 meter. So the distance in the question is just 1,000 meter. Now let's apply this to our question. We have s equal to ut plus 1 over 2 at squared. So the distance is giving us 1,000. The initial velocity is 0 multiplied by the time taken is unknown, t, plus 1 over 2 multiplied by the acceleration is 5, and the time taken is just t squared. Now we've just input all our quantity down into the equation. We have 1,000 equal to 0 multiplied by t will give 0. So that is gone. We have 1 over 2 multiplied by this, and at the end of the day we should have 1 over 2 multiplied by 5 multiplied by t squared. And if we have to resolve all this, we have 1,000 equal to 1 multiplied by 5 multiplied by t squared gives us 5t squared over 2. Okay, so that's what you're going to have. Then we'll balance this one and cross multiply. So let's cross multiply. We have 5t squared multiplied by 1 equal to 1,000 multiplied by 2. Then we are going to have 5t squared equal to 2,000 when we do the multiplication of this. Now we are looking for t, but 5 is being attached with it. We divide both sides by 5. This cancel out this. We have t squared equal to 5 in 20. That gives 4. 5 in 0, 0. 5 in 0. 5 in 20, that's 4. 5 in 0, 0. 5 in 0, 0. So we have it to be 400. All we have to do is to take the square root of both sides to cancel out this square. So this go with this. We have this also. This square is going to cancel out the square root. So we have t. Square root of 400 is just 20 seconds. So the time taken for this body to move from rest and accelerate at the rate of 5 meters per second square and cover a distance of 1000 or 1 kilometer is just 20 seconds. Welcome back, guys. We have another question we are going to treat now. Let's go ahead and just quickly wrap it up and see what we have. A particle starts from rest. Our initial velocity is 0 meters per second and move with a uniform acceleration of 4 meters per second square. So we have our acceleration to be 4 meters per second square. What is the velocity? We have v, which is unknown, after covering a distance of 8 meters. Now, if we are just going to go through all the formula that we have, we'll see that the best equation to solve for this is the third equation, which says v squared equal to u squared plus 2as. So we have v squared equal to u squared plus 2as. Now we have our velocity, which is unknown, so we kindly represent it with v squared equal to u squared is initial velocity, which is just 0 squared, plus 2 multiplied by the acceleration of the body, which is 4, then multiplied by the distance, which is 8. So we are going to have v squared equal to 0 plus 2 times 4 is 8, so we have 8 times 8 to be 64. Now we have v squared equal to 64. Now for us to find v, we need to take the square root of both sides. So we have v squared equal to 64. Then we take the square root of both sides. This cancel this. So we have our velocity to be what? 8 meters per second. So our final velocity of the body is 8 meters per second. We have our initial velocity to be 0 meters per second. The acceleration of that body to be 4 meters per second square. We are asked to look for the final velocity, which is v, after covering some distance, which is 8 meters per second. The best formula to apply in this type of question is v squared equal to u squared plus 2as, because all our data are being available in the equation that we have now. So v squared is unknown, that's why we are still representing it with v squared, because this formula or the equation is having square. Now we have the initial velocity to be 0, then we have square plus 2 multiplied by acceleration is 4, then multiply by the distance, which is 8. Now we have v squared equal to 0 squared means 0 times 0, definitely it will give 0, plus 2 times 4, which is 8, 8 times 8, which is 64. Now we have 0 plus 64, that's 64. Take the square root of both sides for us to get v, that's what we just did here. Then we have v to be 8 meters per second. Welcome back, my wonderful learner. In this question, we are just going to be solving different forms of questions from the one we've been practicing on. Now let's look at the question. A motorist traveling at 120 km per hour sees a broken down truck. You can be traveling, then a truck will just be visible to you on the road that is broken. What do you do in this case? You have to apply your brake, which is retardation. Broken down truck at the middle of the road, and immediately apply his brake and comes to rest or comes to stop with uniform retardation in 20 seconds. What distance does the car travel after this brake were applied? Now let's bring out our data before we can determine the best equation to solve this question. A motorist traveling at 120 km, that's our initial velocity, which is 120 km per hour. Now some of you will be wondering that why am I using the initial velocity? I've explained that earlier on, that the first velocity given to you in equation of motion is your initial velocity, and when you are told that the body is at rest, you make the initial velocity to be equal to 0. But before we move on, we need to do the conversion for this. We can't just make use of it because of the data that we have in the question.
We have 120 to meter per second. We have 120 multiplied by 1000 over 3600, and that's going to be, after we resolve everything, we are going to have 33.33 meter per second. So we have it to be 33.33 meter per second when everything is being resolved. Sees a broken down truck at the middle of the road and immediately applies his brake and comes to a stop with uniform retardation in 20 seconds. Thus, when he applies the brake, the time taken for this car to come to stop is 20 seconds. What distance does it cover? So we are solving for distance now. Does the car travel after brakes were applied? Now, if you are going to run through down to the formula that we have earlier on, the best formula to solve for this is the fourth one, which says S equal to U plus V, or V plus U, into bracket of T divided by 2. Now let's move on. We have S equal to, the initial velocity is 33.3, so we have this to be 33.3 plus the final, since the body is coming to rest, okay, when it says after this brake has been applied, it means the final velocity is 0 divided by what? 2. Everything multiplied by, the time taken for this to happen is 20, so we have this to be 20. So we have this equal to 33.3 plus 0 is 33 multiplied by 20, which we have 666.6. Now divide by 2, we have our distance to be 333.3. Okay, so this is what we are going to have, 30 meter. So this is the distance covered by that body. When he sees this truck and decides to apply brake, he's going to cover the distance of 333.30 meter. If this is your first time of coming across my YouTube channel, please kindly press the subscribe button at J Math and Science. Share to other group. I will appreciate. Thank you so much. Thank you for your time.